Hi everybody, this is Mr. Roche. We are working with the Pente game um, to to work on the initial move of the blue stone. As we know that when you play, the blue stone has to move outside of the square on its second move in order to play fair. Um, I have this working, and I wanted to show you how I did it. I think other people have gotten this going too. Right now, I'm playing computer versus computer, but you can see what it's doing here. Let me start a new game, um, and so what happens is the second move will show up out here, which is right, and that's good, and then they can play. And I think this will help our games, and we'd like to get this kind of functionality in the final version of it. So I want to show you what I did to get this going. And you can see like I'm kind of behind on offense, like my moves are kind of slow, but but still working on it. So let's see. So I'm more about defense, but you can see how this works. I'll show you like three times that it's sort of doing this. We can start a new game even. I think I can start a new game. Oh, maybe I can't with the computer, right? So anyway, that's what's going on. Okay, so the way this can work is that we already have a lot of like sort of functionality already built in for this, because when a player clicks already, and we don't have computers playing, um, you know, we just have two regular people. The first person can click here, but the blue move moving again can't do it. We already have something that sort of checks for this. It won't let them move through. See it? So we have this, and this is already built into the game board. Okay. So, and what we have to run this is we have a Boolean variable that called dark star move to taken. Okay, it's a little bit long-winded of a variable name, but we have that, and then we also have let me go over here to find it. In game board, we have a function called dark square problem. Okay, dark square problem is a good routine because you send it a row and a column, and it will tell you true or false whether there's a dark square problem. And if it's not, it it um it um it will allow the move basically to go through, and it'll change this dark stone move to taken um, to true, so it won't like trigger again. Okay, and this is all like maintained already by Pente Game Board. Okay, so what we need to do is get this functionality to happen in the computer move generator, and that's all we're doing. We're kind of like using this stuff here to and working it in computer move generator. But computer move generator can get a hold of the game because it knows this. Okay, and it just needs to know like the status of this variable, basically. Where is it? It's this variable, okay? And we practice something called data hiding because we love that, okay? So what we need to do is get this variable, like make a method that will let this game be able to show this variable, okay? So I was doing this with Ryan in class, but at the bottom of this, what we did was we made a Boolean routine, like a getter, okay, a getter method, okay, or an accessor method they call them also, okay, to get this variable, okay. So there it is. We don't even have to have this on this. Um, so you just do this. You say get dark star move taken, and then you can see it, okay. So the idea is that with this ability to see this variable and this ability to run this method here, we can do what we need to do over in computer move generator. Okay, and here's how this kind of works. Okay, when you do a computer move, let's look at this for a second. When you do a computer move, what happens is you generate all these possible moves that you could move to. Okay, so let's say I'm the computer here. Okay, and the computer's playing like Betty. Okay, and basically Betty might move here, okay? And the computer generates moves around Betty's move, basically. Okay, it'll generate 1, 2, 3, 4, 5, 6, 7, 8 moves if Betty moves there. Okay, and then if Betty moves here, it'll generate like the possibility around here or possibly around there. Okay, and if I keep doing this, like it'll do stuff like that too. Okay, so it leaves this one alone. But as soon as I do this, it smartens up and goes, oh, I better capture that, right? So that's kind of what happens. When you move here, okay, what's going to happen is the move generator is going to moves right around here, okay? And if you're doing offense, it'll also move around here, okay? But the trick is that we let them on our move list. We have this thing called the move list. Let me see if I can find it. It's here, okay? And we changed it today to the all moves instead of, we had offensive moves and defensive moves, and we're combining them. So all moves, you only have one singular array list that holds all the moves. But what happens is the moves also show up in we have a centralized place to make the moves too. So when you find a move with one of your things that like find 3 def or find 1 def or find whatever, they all find the moves, but there's this one routine that kind of sets the move. Okay, it's called set move. And what we were doing today in class, some kids were expanding this to allow for this idea that if it's a bad move on a Blackstone problem, then don't let it on the list. Okay, that's what's going on. Okay, so what he did was we have in set move this basically, and we weren't doing it. There was no conditions on it. As soon as you sent it the move, it would make a move object, stick the information in it. It actually made them all defense. We have to kind of change that. And then we add the move to the list. Okay? So, and that's a good thing. And then, so what I did was, though, is I added some conditionals to this. Okay? And basically what I need to know is if this is a Blackstone move where the dark star move taken is false. That's basically what's going on. So if you haven't taken your second move and you're a Blackstone, then you fall into this part of the code. Otherwise, the whole game runs through here like it used to. Okay, this is the old stuff, and the whole game runs like it used to, except for one move. Okay. Okay, so only one computer move this really affects, okay? So we have to do this though, okay? So what we do is we go like this, okay? So set move is called by like your move finding functions, like def3 here, def3, def2, okay? They're finding these things. These routines over here are calling this every time it finds a move. So what we're doing though, and so what we're going to do is, so this is like the gatekeeper of getting on the list, okay? And what we're going to do is we're going to first check to see if you're playing for the Darkstone, right? And then we're also trying to see if it's your first real actual move. That's how this is. So what I'm doing is I'm making an if statement, to see if you're Blackstone and to see if the move taken is false, okay? If that's true, then we have to call up the function that checks on Darkstone stuff, okay? So this is a call to the Darkstone problem, okay? So it's calling this. So it's just running this, and we already ran this, and we already run this, and this runs well, and so we don't have to like worry about it or anything. But if it comes back true, then we're gonna it means there's a Darkstone problem, so we're gonna throw this off, okay? But if it's not true, if it comes back false, like no dark square problem, then it's going to make the object stuff, okay? Just like it did before, okay? So either you get on the list or you get thrown out, okay? And this is what this thing does. Okay, so let's watch this work for a second, okay? So starting a new game. This is the computer versus Betty. So what's going to happen is if Betty moves here, okay, these are all good moves, right? It's not a problem. But if Betty moves over here, these are all bad moves, okay? So these never make the list anymore. And if there's nobody on the list, then what we're going to do is we're going to like generate a random move. Okay, that's what happens. So let's look at what happened right here. So we had a situation where Betty moved here. Okay, and so in generating the possible moves around Betty, we generate these like 1, 2, 3, 4, 5, 6, 7 moves, because bluestone would just be like a not a move for us, right? So if I go over here and look at what happens, we go like this. And I put some air checking in for this, okay? So what's going on is it's looking around for stuff. But what happened here with the darkstone problem is that these are from old games. Like I can restart the game, and you'll see like this will clear it and stuff. So if we go here and run this, okay, so this is like computer versus Betty, okay. And what happens is Betty moves like here, okay. And what happens is, see, the move at 9, 10 is getting thrown out. And so 9, 10 is 1, 2, 3, 4, 5, 6, 7, 8, 9, okay. And then it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That move is being thrown out, okay. I don't know if like that's right exactly. Let me see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it's down here. That's right. So this move's being thrown out, okay? And then the 11th move's being thrown out, okay? And then this is 10, right? And this is 9, that's being thrown out, right? And then this is 10, 11, it's being thrown out. And then 11, 9, 11, 10, and 11, 11. So these are all being thrown out. So then what happens is, if there's no moves, and you have to generate a random one, then what I'm doing is I'm being very careful and generating the random move like right around this edge right here. Okay, and that's why this shows up here. Okay, so what would happen then, and I can show you how this works, is that, okay, so all I did was I added some code here, so you have to sort of see this part, right, and make sure that you get this part happening. Okay, and basically it's 2 if-then statements, right? So if this big thing, then do something special, or do what we used to do. And then inside this part of the special thing, you have to have an if-then statement. Okay? So, you could stop the code or stop the video right now to get this right. Okay? And then we'll move on to the other stuff. Okay? I'll show you it. Okay. So where we actually do the moves is up in the get move place. It's here. Okay. So you guys have this. Okay. You have this get computer move, and what it does is it's going to generate this move. This is the coordinates for the move. We initialize them at -1, just so we know that it's not on the board and we're not picking crazy moves. We clear the array for collecting move information, and then we send ourselves off to go find moves. And this find moves calls up all your move finding things. It calls the 1-def, 3-def, the 3-defs here, the 2-def, all these things get called. And I have to work on offense ones. I don't have them yet, okay? But mine's going to call offensive things very soon. And then what we do is we sort the priorities using the array list sorting capabilities, okay? We print them. I print them so I can look at them, okay? And then we do this. This is where we make our move. Dun, 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 dun. And what happens is, if the move list has something in it, which means its size is bigger than 0, right? Then what it will do is we create our move object, right? Or no, we have our move. We're setting up to get the move, right? And then what we do is I do this thing right here to kind of, if they're all like really low, like singular, like moves of low priority, I pick just a random one, okay? But otherwise, basically what we do is we get the first move off the list, because that one, because it's sorted, should be the highest. Because we do this get 0 should be the highest priority move. And it is. We worked to get that to happen, right? And then what we do is we load that move into an array to hold the row and column where we're going to move it. And we send that back up till we get the move put on the board. That's what happens, okay? And then in this, what happens is there's a special situation if you have a problem here.